Welcome to our deep dive.
Hey there.
Let's just set the scene for a second here. Picture this.
Okay.
You're prepping for a solo workout in your living room later today.
Yeah.
You've got your mat rolled out, your water bottle is ready, and you pull up a fitness video on your phone.
We've all been there.
Right. So you start doing some squats, but almost immediately, that little voice of doubt creeps in. Are your knees caving in? Is your back straight enough? You try to, crane your neck to look at yourself in the mirror while holding a heavy weight, which is
Awkward.
incredibly awkward and honestly, probably dangerous. You are trying to follow the trainer on the screen, but that trainer has absolutely no idea what you are actually doing.
Yeah, it is a remarkably common and deeply frustrating experience. You put in the physical effort, you carve out the time, but you are operating completely in the dark regarding your actual execution.
Exactly.
The application you are using is just broadcasting a signal. It isn't receiving any information about your physical state.
And that one-way street is exactly what we are tackling today. We have a massive, really fascinating stack of source material in front of us. Developer walkthroughs, technical blueprints, and the actual project documentation for an MVP called Fit Live Frame AI.
Built specifically for the Gemini Live Agent Challenge 2026.
Yes, the mission of this deep dive is to explore how this specific project is moving artificial intelligence beyond just, typing prompts into text boxes.
Right, moving into physical space.
Exactly. We are looking at a real-time, vision-enabled coaching system that completely solves what the developers call the home workout feedback void.
That's the core of it.
Okay, let's unpack this. What exactly is this feedback void, and why is it such a systemic problem for people trying to stay fit at home?
So the feedback void is essentially the inherent architectural flaw in how we consume home fitness content today.
Okay.
When you follow a YouTube video or a standard fitness app, you are interacting with a one-way mirror.
A one-way mirror.
Right. The trainer on the screen speaks to you. They demonstrate the movement with perfect biomechanics. But the application is entirely blind to your physical reality.
I can't see you.
It cannot tell if you are matching that movement or just completely compromising your joints.
So it's essentially a passive viewing experience that's, masquerading as an interactive one?
Precisely. And the documentation highlights two major consequences of this void.
Okay.
The first is pure physical danger. When you are performing high-risk movements, things like heavy deadlifts, overhead presses, weighted squats.
Form is everything.
Form is absolutely everything. If you are doing these movements with dangerous form because no one is there to physically cue your posture, you are risking severe chronic injury.
Which defeats the whole purpose of working out.
Exactly. And the second consequence is psychological. The developers call it the motivation gap.
Motivation gap.
Yeah. Working out completely alone in your living room lacks the psychological presence and the immediate accountability of a real human coach standing right next to you.
It's just you and a screen.
Right. It is a major reason why home workout routines have astronomically high dropout rates. People just fade away.
That makes a lot of sense. You get hurt, or you just get bored because nobody's watching, and you stop. But the solution these developers came up with to fill that void is wild. They introduced something called the Shadow Mentor.
The Shadow Mentor, yes.
And from reading the blueprints, this isn't just a voice assistant telling you to push harder. It is a real-time 3D digital twin.
Yeah.
Picture a high-fidelity human emoji avatar built using a 3D graphics library called 3.js. This avatar lives on your screen and physically mirrors your exact poses in real time.
If we connect this to the bigger picture, this completely changes the paradigm of solo training.
How so?
By mapping and mirroring your poses instantly, the software takes an isolating, lonely workout and turns it into a shared, interactive spatial environment.
Like a game.
Very much like a game. You are no longer just watching a flat video. You are moving in tandem with a digital reflection that understands your physical space and your body mechanics. The developer's vision here is to turn a standard consumer smartphone into an elite sports lab.
A sports lab in your pocket sounds amazing. But to make a sports lab actually functional, it has to be lightning fast.
Oh, absolutely.
Which brings us to a massive hurdle they had to overcome, the need for speed. The documentation notes that standard AI video processing usually takes about 2 to 4 seconds to analyze a frame and return a response.
Which is way too slow.
In a workout context, a 4-second delay is an eternity. If I am doing a heavy squat and my form breaks, 4 seconds later I might have already slipped a disc.
Yeah, the moment has passed.
So how on earth did they engineer this to work in real time?
Well, that latency issue was one of their most significant engineering challenges. To achieve true real-time performance, they had to build a highly optimized custom pipeline.
Okay, walk me through the pipeline.
The data flow starts with your smartphone's webcam and microphone capturing your raw video and audio. That data is then transmitted via secure WebSockets or WSS.
Let's pause there for a second because I want to understand the plumbing here. Sure. If a standard web request like HTTP is basically like mailing a letter to a server and waiting days for a reply, how does secure WebSockets change that dynamic to prevent that back and forth delay?
That is a great analogy. Standard HTTP requires opening a connection, sending a request, waiting for the server to process it, receiving the response, and then closing the connection.
Lots of steps.
Too many steps. Doing that dozens of times a second for video frames creates enormous overhead and lag.
So what does WSS do differently?
Secure WebSockets establish a persistent bidirectional communication channel.
Persistent.
Right. The connection is opened once and stays wedged open. Data can flow back and forth simultaneously without the constant handshake overhead.
Oh, so it's just a continuous stream.
Exactly. That continuous stream flows directly into a serverless Google Cloud Run backend, which automatically scales compute power based on the intensity of the workout data.
So the pipe is wide open and the server can handle the flood of data.
Yes.
But the real magic seems to be how the AI handles that continuous stream.
What's fascinating here is their use of the Agent Development Kit, or ADK.
ADK.
Right, combined with bidirectional, or BD, streaming at the model level. They leveraged the Gemini 3 Flash model for this.
And the documentation mentions they had to migrate to that.
They did. It specifically details a high-speed migration from the older 1.5 Flash model because the older architecture simply couldn't handle the token frequency required.
It just couldn't keep up.
Exactly. By moving to Gemini 3 Flash with BD streaming, they managed to drop the processing latency down to under 200 milliseconds.
Under 200 milliseconds. Now, that sounds incredibly fast on paper, but human reaction time is generally around 250 milliseconds.
Right.
Is that slight edge actually fast enough to stop someone who's already midway through a heavy, dangerous deadlift drop?
It is, because the AI isn't just reacting to the end state of the movement. It is analyzing the velocity and trajectory of your joints in motion.
So it sees where you're going, not just where you are.
Exactly. It can predict a catastrophic form breakdown just before you reach the point of no return.
That's crazy.
And that predictive speed powers their primary safety feature, the roadblock interruption logic.
I love this feature. They actually use a little construction roadblock emoji in the source code to annotate it.
They do. It's very fitting.
If your form precision drops below professional safety standards, say, the AI detects your lumbar spine is rounding on a deadlift, or your knees are starting to cave inward on a heavy squat.
It steps in.
Right. It doesn't just quietly log a bad score for you to review later. The AI physically interrupts you in the moment.
It acts as an active safety mechanism, functioning almost exactly like a human spotter stepping in to grab the bar.
The mechanics of it are just brilliant. The 3D avatar on your screen literally stops moving, breaking the mirror effect.
Which instantly grabs your attention.
It points directly to the specific error on its own digital body, and then the system triggers VO 3.1.
A completely secondary model.
Yeah. The secondary model instantly generates an 8-second high-fidelity 4K instructional video clip showing you the absolute perfect biomechanical form for that specific moment of the exercise.
It stops you, corrects you visually, and resets you before you get hurt.
Like a coach pausing the game.
Exactly.
Yeah.
But the interactivity extends beyond just visual interruptions. Through the integration of the Gemini 2.5 Flash native audio model, the system supports highly natural, bidirectional verbal conversation.
Native audio.
Yes, because the model is natively processing audio, meaning it isn't wasting time translating your voice to text, analyzing the text, and translating text back to a synthetic voice. You can engage the coach directly.
So if I'm unsure about my posture, I don't have to wait for the roadblock to trigger.
You don't. You can be completely out of breath in the middle of a repetition and just ask out loud, "Is my back straight?"
And it just answers.
Instantly. The system hears you, instantly analyzes the current spatial frame of your body, and gives you a context-aware verbal answer in your ear. It is a true two-way dialogue while you are under physical exertion.
Here's where it gets really interesting, because achieving that level of real-time analysis is one thing when you have a live streaming camera feed actively talking to a server. But the documentation mentions another massive technical hurdle. The app also allows users to upload pre-recorded video files for analysis.
Yes, for post-workout review.
Say I film my workout at the gym and want to review it when I get home. How does a standard web browser handle an AI analyzing a massive 7-gigabyte 3-hour video upload without just completely crashing the tab?
That scenario required a brilliant piece of client-side engineering that the developers refer to as the infinite video fix.
The infinite video fix.
Yes. Typically, when you upload a video for AI analysis, the entire file has to be transferred to the server's memory.
Right, the whole chunk.
A 7-gigabyte file would immediately hit browser memory heap limits and result in a payload too large error before the analysis even began.
So you're stuck staring at a frozen screen or a crash report.
Exactly.
How do they bypass the server upload entirely?
Instead of uploading the file to Google servers, the system processes the video locally right on your device's browser.
On the device itself.
Yes. It utilizes a 2 to 15-second dynamic heartbeat interval. Every time that heartbeat pulses, the system essentially takes a localized screenshot of the video exactly as it plays on your screen.
It's actively sketching out frames as the video rolls.
Precisely. It draws that specific frame to a hidden canvas element buried within the browser's background processes. Then, to ensure the data remains incredibly lightweight, it actively downscales the image resolution to exactly 1280 pixels.
Okay, shrinking it down.
Finally, it converts that downscaled image into a compressed base64 string and sends only that string to the AI.
Now, wait a minute. A base64 string is just a giant wall of alphanumeric text.
Yes, it is.
Why are they converting a picture of me squatting into a giant paragraph of text to send to an AI? Why not just send the image?
That is the core of the hack. Large language models at their foundational level are designed to process text tokens.
Oh.
By converting the downscaled image into a base64 text string, the developers are essentially tricking the AI's text model into reading a video frame as if it were a complex paragraph of code.
Tricking the AI. That's so smart.
This completely bypasses the need for heavy, traditional video processing APIs, which are notoriously slow and resource-intensive.
They disguise the video as a text prompt to sneak it through the fast lane.
Exactly.
That is incredibly clever.
Yeah.
But what happens if the AI takes a second too long to process one of those text frames and the video just keeps playing and taking more screenshots?
Ooh, the backlog.
Yeah. Doesn't the browser eventually choke on all those queued up frames?
The developers anticipated that traffic jam. They implemented a pending frame queue that acts as an asynchronous buffer loop.
How's that work?
If the AI is still processing the previous frame, the system simply waits, holds the video playback state, and queues the new frame.
So it pauses behind the scenes.
Right. It strictly regulates the flow so it never overwhelms the network with simultaneous requests. This ensures the application remains stable even over a 3-hour continuous analysis.
That solves the data traffic jam beautifully.
It does.
But I have to ask about the actual vision capabilities themselves. I understand an AI can analyze a 2D image or a text string. But counting a complex repetition, like knowing if I actually dropped my hips low enough on a squat, requires understanding 3D space.
Spatial awareness, yes.
How did they extract a z-axis or depth from a standard, flat 2D smartphone lens?
The insight here is profound. It didn't just build a rep counter, they figured out how to turn a basic consumer camera into a spatial LiDAR scanner using purely predictive AI logic.
A LiDAR scanner.
Functionally, yes. The technical magic relies on forcing the AI into a highly specific analytical mode by utilizing Gemini's thinking level high setting.
Thinking level high.
This forces the model to perform deep spatial reasoning rather than simple surface-level image recognition. It calculates the mathematical probability of where your limbs must be in 3D space based on the overlapping angles in the 2D plane.
So it's deducing depth by looking at the geometry of how my body parts obscure each other.
Yes. But to make that usable for the 3D avatar, the developers achieved this by forcing the AI to output what they call strict JSON thought signatures.
Okay, a JSON thought signature sounds like something pulled straight out of a cyberpunk novel.
It does sound sci-fi.
Break that down for us.
JSON is a lightweight data interchange format. In this architecture, instead of letting the AI write a paragraph describing your posture, they demanded the AI return stripped, atomic packets of data.
Just raw data.
Exactly. These packets contain highly specific Y and X coordinates for key biomechanical joints: the head, the shoulders, the hands, the hips, and the feet.
So it's extracting a hidden digital skeleton from the video frame and plotting it on a graph.
And those specific coordinates are directly mapped onto the skeletal rig of the 3JS 3D avatar we discussed earlier.
Right, the Shadow Mentor.
Because the AI is constantly analyzing the travel of these coordinates, for instance, measuring exactly how far the hip coordinates sync in relation to the knee coordinates along that deduced z-axis.
It can track the actual movement in 3D.
It can accurately increment your repetition count. And importantly, because it tracks this coordinate travel persistently, your rep count won't randomly drop to 0 mid-set just because you paused or the AI had to give you a coaching cue.
That's always so annoying with older fitness apps.
It maintains a constant, unbroken spatial awareness of your body.
It knows exactly where you are in space at all times. That level of precision engineering is just staggering.
It really is.
But reading through the blueprints, it's clear that FitLive Frame AI isn't just a clinical, sterile piece of medical tech.
Not at all.
They put a massive amount of effort into the atmosphere. The UI is described as having a premium glassy aesthetic, custom-built with React and Tailwind CSS.
Yeah, the design language is very deliberate.
It looks less like a medical device and more like a high-end sports lab dashboard.
They recognize that user experience and atmosphere are critical components in solving that psychological motivation gap we talked about.
You want to feel cool using it.
Exactly. The aesthetic design is intentionally crafted to make the user feel like they are interacting with elite, professional athletic equipment, which elevates the entire training experience.
And that premium atmosphere isn't just visual, it's auditory.
The audio is fantastic.
This might be my favorite quality of life feature in the whole document. They integrated Laria 3 to generate dynamic 48 kilohertz stereo workout music.
Not just a standard playlist.
Right. But it's not just static music pumping in the background. It acts as a tempo sync.
The adaptive audio is a brilliant application of multimodal data blending.
Multimodal.
Yes. The generated music physically breathes with your workout. The system takes the velocity data of your physical movements, literally tracking how fast you are completing your repetitions based on those JSON coordinates, and uses that real-time data to dynamically adjust the beats per minute, or BPM, of the music.
So if I speed up,
If you speed up your exercise intensity, the music dynamically speeds up and layers in more instrumentation to match your energy output.
it's like having a personal DJ in the room, matching the bass drop to your exact heartbeat.
It's incredibly immersive.
But wait, I have to play devil's advocate here.
Go for it.
If the music dynamically speeds up when I move faster, wouldn't that just encourage me to rush my reps, compromise my posture, and totally ruin the safe form we just spent all this time trying to protect?
That is exactly where the systems counterbalance each other.
Oh.
If you let the music push you into a sloppy, rushed repetition, your coordinate precision drops.
And then the roadblock hits.
The moment that happens, the roadblock interruption logic triggers. The music cuts out, the avatar stops, and you are visually corrected.
That is so punishing, but in a good way.
You quickly learn that to keep the high-energy music pumping, you have to maintain speed and perfect form simultaneously. It gamifies strict biomechanics.
You have to earn the tempo. That is a brilliant design loop.
It forces discipline.
And speaking of earning things, the post-workout rewards described in the documentation are incredibly thorough. When you finish a grueling session, you don't just get a simple "good job" pop-up screen. You receive a comprehensive shadow report.
That report is generated by the Gemini 3.1 Pro model.
A Pro model, so not the Flash one.
Right. Pro specializes in deeper, long-form synthesis and analysis rather than the rapid-fire streaming of the Flash model.
So it takes its time to give you a real breakdown.
Exactly.
The shadow report details your average form precision across the entire workout, your exact calorie burn based on the physical effort tracked by the 3D model, and it gives you a highly personalized key takeaway for your next session.
All of this data is persistently stored in Google Cloud Firestore, so you can track your biomechanical progress over months or years.
Which is great for long-term goals. Oh, and the system also generates custom victory posters using Nano Banana 2.
The Victor posters are a fun touch.
These are stylized images featuring your specific 3D avatar and your workout stats, ready to be shared on social media.
It creates a complete, satisfying feedback loop of effort, correction, and social reward.
It covers all the bases.
However, this raises an important question.
Okay.
With all this automated coaching, spatial tracking, and personalized posture feedback, How do we know the AI's coaching advice is actually medically sound?
That's a great point.
Large language models are prone to hallucination. How do we know it isn't giving you dangerous advice based on a flawed spatial calculation?
That is the ultimate deal breaker for AI in the fitness space. If it gives bad advice, people get hurt.
The developers address this critical safety flaw through what they call their athletic intelligence system.
Athletic intelligence.
They didn't just let the AI guess at what good form looks like based on its general internet training data. The coaching agent is strictly grounded in professional fitness guidelines and established biomechanical standards.
Where do they keep those standards?
They stored these professional medical guidelines within a Vertex AI vector search index.
How does a vector search actually ground the AI in reality?
Instead of just looking up the word squat in a text database, vector search mathematically maps the 3D angles of your joints, those JSON coordinates, and finds the closest, nearest neighbor in its database of medically safe postures.
Nearest neighbor.
Yes. Before the AI is allowed to speak or interrupt you to correct your posture, it cross-references its visual analysis against this geometric database of established sports medicine criteria.
So it double checks itself.
It ensures the feedback is safe, accurate, and scientifically validated before it reaches your ears.
So it's continuously consulting a mathematical rulebook of sports medicine before it ever opens its mouth.
Exactly.
That is very reassuring. We have covered a massive amount of ground here today. We've traced the evolution from the danger of blind, one-way home workouts.
The feedback void.
The feedback void, yes, to a system that uses bidirectional zero-lag video, audio, and spatial tracking to put a hyper-intelligent sports lab right in your living room.
It is a
Yeah, the source material actually lays out a pretty incredible roadmap for the future of Fit Live Frame AI.
The development roadmap suggests they are moving aggressively toward integrating with emerging wearable and visual hardware.
Hardware integration.
First on the list, they plan to port the entire application to Jetpack XR for AR smart glasses.
Moving from the phone screen to augmented reality.
Exactly. Instead of having to look at the 3D shadow mentor on your phone screen across the room, you would put on smart glasses.
Oh, man.
And the digital twin would literally appear to be standing right next to you in your physical space, demonstrating the perfect form in 3 true dimensions.
Having a holographic coach in your living room, that is just incredible.
They are also actively working on syncing the spatial vision system with Wear OS.
Smartwatches.
Yes. By pulling high-frequency heart rate, HRV, and blood oxygen data directly from a smartwatch, they can combine those internal biometric signals with the external vision data from the camera.
Internal and external data.
It creates an incredibly comprehensive metabolic and physical profile. The AI will know your form is breaking down before you do, simply because it sees your heart rate spiking.
And lastly, the documentation mentions upcoming multi-user squads.
The social element?
You'll be able to link up with friends remotely, and all of your 3D avatars will populate in a shared augmented digital space. You can compete live on a precision leaderboard while working out in entirely different time zones.
It totally eliminates that psychological motivation gap. It leverages the core technology not just for physical correction, but for community building and accountability.
It's a brilliant way to keep people engaged. Now, before we wrap up, I want to leave you with a final provocative thought.
Okay.
We have spent this whole deep dive talking about squats, deadlifts, and fitness. But let's zoom out for a second.
And what the bigger picture?
If artificial intelligence can now perfectly map, synchronize, and correct our complex physical movements in 3D space with zero lag, using nothing but a standard smartphone camera and a clever Base64 trick,
Yeah.
what happens when we take this shadow mentor concept outside of the gym?
The potential applications across different industries are virtually limitless.
Imagine applying this exact bidirectional visual feedback loop to learning a complex physical trade, like welding or carpentry. The AI could physically interrupt you if your torch angle is off.
Yeah.
Or imagine trying to master a musical instrument.
That's a great example.
The AI could watch your hands on a piano keyboard and correct your fingering technique in real time. Or, perhaps most importantly, imagine doing post-operative physical therapy at home, where a digital twin ensures you are doing your precise rehabilitation exercises with absolute medically grounded accuracy.
Completely eliminating the risk of re-injury.
Exactly. The gym is just the proving ground. The real revolution here is in how we are going to learn and master any physical skill in the future.
It truly is a glimpse into the next generation of human-computer interaction. The screen is no longer a barrier. It is becoming a collaborative, spatial workspace.
Beautifully said. That is all the time we have for today's deep dive into FitLifeFrame AI. Thank you so much for joining us. And as always, keep exploring, keep questioning, and keep learning. Catch you next time.